So changing magnetic fields create current. Keyword is that it has to be changing. Okay? So a changing field has to create a current, or vice versa. Or you can have current creating a magnetic field. And you've actually already seen this. So I showed you this demo last time where I dropped the magnet through the copper wire, and we found that when you drop the magnet just on its own, right, when you drop the magnet on its own, it just falls like a magnet because it just, like it's an object, it just falls. But when I drop said magnet through the tube, it falls at a much slower rate. And the reason is the motion of that changing magnetic field through the tube creates current in this tube. And that current creates a magnetic field. And for reasons we'll talk about later, something called Lenz's law, they're always going to be opposites. And so you get this changing magnetic field creating current, and that current creating a magnetic field that opposes the first one, and it causes it to fall much slower. So what would fall at a regular rate inside falls at a significantly slower rate. Okay? And that's this idea of electromagnetic induction. Electromagnetic induction is something you are super familiar with. You just didn't know that you were. It's how power plants work. It's how your car works. It's how everything that does electricity essentially works. If you have one of those wireless charging phones, that's what this is. All of this stuff, electromagnetic induction, is something that's used so often that we're just used to it working. We just don't really know why it does. Okay? The second thing we need to know is something called magnetic flux. And magnetic flux is basically the amount of magnetic field through a loop of wire. So, to show you this visually, because I tried drawing it in my other class, and oh my gosh, it was not great. So let me visually show you what's going on here. That'll be much easier for you to see. Okay. What I mean is this. What I mean is how much field goes through my wire. So if I have my loop of wire here, I said I wasn't going to draw it, I'm going to do it anyway. Okay? If I have my loop of wire, it's how much field travels through. Okay? That's what I'm looking at. So magnetic flux is just a fancy word for how much magnetic field goes through a loop of wire. And yes, this is kind of what a flux capacitor is based off of. Clearly that's made up, but it's made off of based off of this kind of idea. Okay? One last thing to look at here before we jump in and try out the lab and then talk about that is number 3. So what is electromotive force? So electromotive force, first of all, is called EMF. And it basically is an induced, which basically means created. So it's an induced voltage in a loop of wire. So electromagnetic induction is the actual process, okay, of making magnetic fields create current, or the other way around. And magnetic flux is how much current or how much field is going through that loop of wire. And what we get when we do electromagnetic induction is called EMF, electromotive force. And that is essentially a voltage that's created in a loop of wire. So if you're saying to yourself, does that mean I can make a circuit work without batteries? And the answer is yes, you can. Okay? In fact, that's exactly how power plants work, right? Power plants don't have any batteries or anything like that. They just magically make electricity. They do this. They make electromotive force, which is a voltage that's created in a loop of wire. Now, there's a lot more we need to get to, such as what actually affects it in a wire, what is Faraday's law, what's the equation for this, how do we solve. There's a lot to get to. But for right now, let's just play around and see